So if I were going to say, why is it? Here we go with the technical glitches. Now can I write? Now can I write? There we go. Okay. 3 to the 6th power means what? 3 times 3 times 3 times 3 times 3 times 3 times 3. X plus 3 to the 4th power means what? X plus 3 times itself 4 times. Okay, x plus 3 times x plus 3 times x plus 3 times x plus 3. This means, so if you just look at this, what does this mean? 2ab to
Times 2ab times
2ab times 2ab times 2ab times 2ab. So if I multiply that all out, what's 2 times 2 times 2? 2 times 2 times 2, 8. How many a's do I have altogether? A to the 3, b to the 3. We'll learn about some rules, how to figure that out when we write the power rule, but we're not going to worry about that. This means 2 to the 3rd times 2, or 2 over 3 times 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 2 over 3, right? Which is whatever it is, all right? So here is the first rule that you got to know. Oh, first I have to give you plus, yes? All right. I was going to buy a new pretty good joke book, but you know what? My jokes are better than, I don't need to get them from a joke book. I could just make up my own. I think they're better that way. So moving on. Okay. Couldn't you go backwards? Could you go backwards? How could I rewrite this? I'm not going to do it. This is 4 to the 1, 2 to 4 to the 7th, right? This is 4 to the 7th, okay? This is x plus 1 to the 3rd, okay? This is, you don't have to write these down, if you w squared p to the 4th. This is equal to 3 over 7 to the 4th, okay? So that's how you go backwards. So the next thing, I know I'm going fast, but I want to get through some of this stuff. So expand the expression. We're not going to do all this. What is this equal? Who could just tell me what this is equal to? What is that equal to? X cubed is x squared times x squared. What's that equal to? Alvaro is going to tell me.
X plus squared.
X to the what?
Is 5.
X to the 5, not to the 6. You add them, right? Because this means x times x times x, right? And this means x times x. So altogether, I only have 5. So you add the exponents, okay? So how about this one? What's this one equal to? We're not going to do. Whoops, I went too fast. Going back. Where'd that one go? How do I go back? Just go back. There we go. Who could tell me what this is equal to? Raise your hand. Okay? W to the 7. Very good. Okay? Heck yeah. You get an A. Let's stop now.
Yeah,
We'll be done. All right. So moving on. Okay, the product rule says that if you have two expressions to the same base, or this is called the base. Okay? This is the base, and this is the exponent. A to the m times a to the n is equal to a to the m plus n. That's called the product rule. So basically, if you have two things that have the same number down here, all you do is you add up the exponents. Okay? Questions on that? Easy? Let's see if I have some additional. Do you want a minute to write that down? Let me see, what time do we get out? 10:45. Oh, I got lots of time.
Ooh.
Can I move on? Who says I can move on? Can I move on, Chase? Okay, good. All right. So, Chase, what's this answer equal to? 6 to the 8th. Very good. Who can tell me what this is equal to? How many A's do I have altogether?
2. Oh, never mind.
9. but then the numbers in front, you just multiply them normally like you multiply. So what's 3 times 2? 6, 8 to the 9. See the way that works? So if you have numbers in front, you just kind of multiply them together. If you had things that have the same base, then you add them, okay? Who can tell me what this is? Hey, who wants a valuable bonus point? Raise your hand. Raise your hand. Raise your hand. I'll give you a point if you raise your hand, Daniela. Go ahead, Daniela.
Negative 14x to the 5th
Yep.
and y to the 7th.
Yes. Okay. So if there's nothing here with this one, it's understood that there's a 1 there, right? So this is 14x. Oh, I have to give you a point.
Thank you.
Alrighty. Daniela, you. All right. Questions about that? Okay. Moving on. Moving on. Moving on. How come? This what I want? No. Want this, want this, want this. Expand. So, what if I had this? Okay, so I'm not going to do this again in the interest of time. I am going to expand this out. So 3 to the 7th means 3 times 3 times 3 times 3 times 3 times 3. 1, 2, 3, 4, 5, 6, 7. And 3 to the 2 means I have a 3 and a 3 there. How many of those 3's can I cancel out?
2.
Do you guys know I could cancel out 3 divided by 3 goes away? And 3 divided by 3 goes away. So how many 3's do I have left over on the top?
5.
5. So this is equal to 3 to the 5 power. You guys understand that? Yeah? Yes? What I just did? Okay. So moving on to the next problem, similar problem. Who can tell me without actually writing it all out, what's the answer? Without actually writing it all out, what's the answer?
X squared.
X squared. How did you get that? Anna, how did you get that?
No, I subtracted results.
Very good. You subtract the exponents. Because if I did write this all out, you'd have 6 x's up top, right? 6x, okay? And 4 x's down here. And these would cancel that out. 4 of these would cancel out. And I'd be just left with 2's up, 2 x's on the top, which is x squared, right? So that leads us to the next rule, which is called the quotient rule. I think that's the next thing on your sheet, right? So if you have two expressions with a common base, so this number has to be the same, a to the m over a to the n is equal to a to the m, let's try that again, a to the m minus n. So if you have two bases, one on the top, one on the bottom, you subtract that. Easy enough? Right? What if I had, can I move on?
Yeah.
Okay. So I think I have a couple more examples here. Let's see examples. Uh-oh. So, valuable bonus point. Participation points. Other than Daniela, who wants a point? Tell me what the answer is to this. Go ahead there. Matt.
8 to the 11.
8 to the 11. Easy enough? Okay. If it's like this, same idea, but I can actually do the division here. So who could raise their hand and tell me what this is? Go ahead, Ben.
3x to the 6th.
3x to the 6. I'm going to remember to give you your points in a second, okay? How about the last one? Who's got this last one right here? Go ahead, Luna. Perfect. Okay. What? Y to the 6. Do you guys understand where she got that from? She divided this into this, and then she subtracted. There's a 1 down here if nothing's there, right? So you divide that, and then you subtract the exponents. Okay. Wait, I'm giving those people points. Where are those people? Okay. Wait. Weight? I didn't gain any weight because I did a lot of cross-country skiing. So, who gets a point? Luna Walsh. Who else gets a point? Ben. R. Who else gets a point? Matt Brown. You go. It's all okay. So, moving on. Moving on. Copy and complete the first 4 rows. Don't worry about this. But I want to show you something, okay? So say we know that, let's start with 2 to the 4th, okay? Then we're going to go to 2 to the 3rd. Then we're going to go to 2 to the 2. Then we're going to go to 2 to the 1. Then we're going to go to 2 to the 0. And then we're going to go to 2 to the -1. And then we're going to go to 2 to -2. Who can tell me what 2 to the 4th is? What's 2 to the 4th? 16. What's 2 to the 3rd? 8. What's 2 to the 2? What's 2 to the 1? What's 2 to the 0? It's not 0. Okay? How do you know that, Matt?
Because anything to the 0.
Anything, but it also goes with this pattern, right? What am I doing to each of these numbers to go from here to here? I'm dividing by 2, right? Because basically to go from here to here, I'm multiplying by 2, right? So the opposite. So it makes sense that if I divide this by 2, what's 2 divided by 2? 1. Okay? And what would, based on this pattern here, what would 2 to the -1 be? What's not -2? Based on the pattern. It's dividing by 2, so what would this be? It's 1/2. Positive. Okay? What's 1/2 divided by 2? 1/4. Okay? So people always say, why is anything raised to the 0 equal to 1? Because it makes the math work. Okay? So and also negative exponents do not mean you get a negative number. This is equal to 1 over 2 to the 1. This is equal to 1 over 2 to the 2. So 2 to the -3 would be 1 over 2 to the 1 over 2 to the, what goes, if this is 1 over 2, if 2 to the -1 is the same as 1 over 2 to the 1, and 2 to the -2 is the same as 1 over 2 to the 2, what would be 2 to the -3 be the same as? 1 over 2 to the 3, right? Which is the same as 1/8. Yes? If I divide 1/4 by 2, I get 1/8. So that's the next rule. Next rule says that 1 as an exponent, anything raised to the 1 power, a to the 1 is just equal to, a to the 1 is just equal to a. So what's 3,562 raised to the first power?
3,000.
That's equal to 3,562. Likewise, 0 as an exponent is always going to be equal to
1.
anything raised to the 0 is always going to be equal to 1. So a to the 0 is what's not 1? Yeah, is 1. What's 23 raised to the 0? 1. Right? What's pi raised to the 0? 1. What's 3.75 raised to the 0? 1. Very good. What's -1 raised to the 0? -1 raised to 0. Actually, first you raise it to 0, then you make it. So be careful with this. This says first raise it to 0, which is 1, then make it negative. This is equal to -1. But if I say take -1 and raise it to the 0, that's equal to positive, right? So you got to be kind of careful with your parentheses on this stuff. Okay? Good? Yes? I'm going to do a couple more examples, and we'll be almost done. One is negative exponents. So if you have a to the negative n, that's equal to 1 over a to the n. This is what I was trying to show you in the last problem. Okay, so if an exponent is negative, you just bring it down to the bottom and you make it positive. Who knows some of these rules already? Do you guys know these rules already? No? Yeah? Some of you know these. Okay? So, I know I'm going fast, but we have a limited amount of time. So, who can show me how to write 23 to the negative 1 without a negative exponent? What? Go ahead. What did you say, Fred? Yep. This is just 1 over 23. What's this equal to? Wolfie, what's this equal to? Wolfie.
1 to the
1 over
W.
to the positive 4. So if it's negative, you just bring it downstairs and make it positive. Who can tell me what this is? Valuable bonus point. Valuable bonus point. Come on, you can do it. Without any negative exponents. Who could write this without any negative exponents? Trey can. Come on, Trey. No? Kate, what's this? No? How do I make this negative 7 positive? K to the 6 over P to the positive 7. Okay? Just bring it downstairs and make it positive. Okay? Who wants to do this one? Do this one, Everest. This is not sinking in very well. Who's got no? If you got the negative exponent, just bring the base downstairs and make it positive. Anna, you want to try?
Y5 over 3x.
The 3 stays up top. Okay? 3y5 over x squared. Okay? So what it's right? So you just bring the negative downstairs and make it positive. Okay? Yes? No? No? Maybe? You got it? So what if I had do we have negative exponent? Oh yeah, I went through the negative exponent rules, right? That was on, so oh my goodness. What if I had product quotient rule with negative exponents? Oh my goodness. So what if I saw something like this? What do I do with the exponents when I multiply it? Add them. So what's negative 6 plus negative 4? W to the negative 10. What's positive 8 and negative 2? W to this, whoops, I messed up. That should be a U, not a W, right? Sorry. Let's try again. So that's going to be U to the negative 10th, W to the positive 6. But if I want to write this without negative exponents, what do I do with that U? Bring it downstairs. That's equal to W to the 6 on top, U to the 10th on the bottom. Okay? Who can tell me how to do this one? Should be writing these down. It's good practice. Why do you need to know this? Sometimes you need to know how to... It's snowing! Oh. Okay. Who can tell me what this is? Subtract the exponents, Nick. What's negative 3 minus 6?
Negative 9.
10 to the negative 9. Okay? What's that equal to? How can I make this negative exponent positive?
Wait, what is it?
Negative 3 minus 6 makes negative 9. Now I'm going to bring it downstairs and make it positive. So 10 to the negative 3 over 10 to the positive 6 is equal to 1 over 10 to the positive 9 power. Subtract the exponents. What's negative 7 minus minus 9?
2
2 to the
squared.
squared, which is equal to 4. Weird. Huh? You understand that? What I just did? Sydney? 2 to the negative 7 minus minus 9, right? Because negative 7 minus minus 9 makes 2. So 2 to the 2 is equal to 4. Okay. Which leads to the next rule. Next rule. Last rule. How can you simplify this? X to the what? You can do it. Subtract. What's minus 3 minus minus 2? X to the negative 1, which can be written as 1 over x to the positive 1, or just 1 over x. No? Yeah? Maybe? No? You give up? I give up. Negative rule exponent. What? Going back. So, if I have something like this, so say for example, I'm just going to do another little example. Say I have 3 to the negative 3 over x to the negative 4. Okay? I just want to show you this. Okay? This, and this is the last rule. Okay? This can be written as 1 over 3 to the 3 times 1 over x to the 4. Yes? Okay, as a double fraction like that. You guys know copy dot flip, right? 1 over 3 to the 3 times the reciprocal of the bottom. X over 4 over 1. Okay? And when I simplify that, I get x over 4 times over 3 to the 3. See how this is 3 to the negative 3 here, and this is x to the negative 4? How could I quickly have gotten from here to here? If it's negative, I can bring it up top and make it positive. Okay? If it's negative on the bottom, I can bring it up top and make it positive. If it's negative on the top, I can bring it down to the bottom and make it positive. So the second rule says this. A to the negative m over b to the negative n is equal to b to the positive n over a to the positive m. Oh, I still have 5 minutes. So if this is negative, I can bring it downstairs and make it positive. If this is negative down here, I can bring it upstairs and make it positive. Get that? No? Maybe? So, a couple more examples and then we're done, I promise. Okay? Who can tell me how I could rewrite this using that rule that I just learned? Quick. Go ahead, let's see.
4 to the second over 5 to the third.
Yep, 5 to the third. And usually I'd say you could just leave it like that, but maybe I'd say simplify, right? What's 4 to the 2? What's 4 squared? 16. What's 5 to the 3? 5 times 5 times 5? 125. So this would be okay. If I say write it out, it would be like that. Who can tell me how I could simplify this using these rules? Tia.
1 over 9 to the 11.
Not, is it not 9? No, there's no 9. Keep the bases the same. So I subtract the exponents. Oh, not 9 to the 11th.
6.
No, this stays the same. It'd be 3 to the negative 11th, which is 1 over 3 to the 11th, not 9 to the 11th. This doesn't change unless they're two different, like you can't combine them if these are different. So this just stays at 3. Yeah? Yeah. I think you're thinking like if you have like a, yeah, that it's just how it is. You want to try this one? We have 5 minutes. Who wants to try this one? I'll give you $1. 2 bonus points if you get it right. Where are you going?
I just moved my papers.
2 bonus points if you get it right for this one. Simplify it without any negative exponents. You got a minute. Oh, we got 3 minutes. I'll give you a hint. Subtract the x exponents. How do I move that x down to the bottom? Don't go yet. Don't go yet. How do I move the x down to the bottom? X squared. The y, is that a y? There's only a 1y that stays up top. Z goes to the bottom and becomes positive. W goes to the top and becomes positive. V stays down here. Oops, Z to the 9th. Okay? So, okay, last thing. On your, so your homework, okay, I'm going to pause here. Where are you guys going? It's not time to go, guys. Where's my, oh, here it is. Good.